Hi guys, welcome to another Heat Geek one-to-one Zoom episode. This time I'm joined by Rob Stiby, very well known in the industry actually. He's been at Daikin for 30 years and been champion heat pumps probably longer than the vast majority of the people in the industry. And he is the product champion of Daikin. Product champion, yeah?
Product champion, yeah.
Okay, well done. Woo!
We can blame the Europeans for that one.
Okay.
My motivation and my ambitions is obviously I work for Daikin anyway. I mean, I wouldn't work for a company that I didn't like the product for.
Yeah.
But my main goal is actually just trying to get people to understand what's going on. So what you've done over the years has been actually really, really good. I kind of sort of kicked myself and I sort of thought, well, why don't I do that 15 years ago when I started? Because I was one of the first guys to do to write a design course for heat pumps.
Right.
And that was with Daikin, and I was doing that. It must have been 14, 15 years ago. I started doing that now.
I was that would have been when I first started my company, just before I started my company.
There you go. But yeah, that's what I've always wanted to do. I started on the service side of the business. By trade, I'm an air conditioning engineer.
Right.
The products first came out, it must have been sort of 16 odd years ago now. We first started selling them. I think from memory, it was a French company that came up with the concept, and they were using the Daikin outdoor unit. And Daikin sort of seen the appeal with it, and they took the product on board. I mean, heat pumps obviously been around for donkey's years anyway. So
yeah, but so the air to water, like that was where it kind of spun off of, basically.
Obviously, we've been selling heat pumps ever since I worked for Daikin.
Yeah.
Which has been 30 years now.
Wow.
Yeah, just a little bit. But as soon as the heat pump or the air to water systems came out, should I say, I jumped on the bandwagon very quickly and wanted factual information. So I got heavily involved with the training at that time, creating the training courses for the service side of the business and delivering the training courses. So if you were ever on a Daikin training course for heat pumps back then, you possibly might have even had me.
Right.
A little bit slimmer back then.
Yeah.
And then I got so involved and I realized actually to make a big difference to the industry, I needed to be on the forefront of the business. So I actually moved across to the sales side.
Yeah.
And I was effectively sort of pre-sales technical at the time. And that's when I created the design course to try and help specifiers. And it was silly little things back then. It was just trying to get underfloor heating companies to understand that with a heat pump, we've got this 5-degree delta T, and you need that flow rate going for the underfloor heating. So they need to make sure they actually put big enough piping in, and then obviously to go for super low flow temperatures, getting the pipes as close as possible. And it was just trying to get it into the industry, right, to develop it and deliver it.
I mean, it's still incredible now that underfloor heating companies spec the least they can get away with quite often. Like to see a design now with 300 mil centers of underfloor heating is absolutely mental. Like that, you are nothing to do with this industry if you think that's okay.
Yeah.
Although it can work, that doesn't mean it's best. Like I think we've come quite far, but we've still got a hell of a long way to go still in the industry.
Massive. It's difficult for me, and I must admit I try and stay out of the sales side of the business because this is where price is driven. It's nice for me to sort of sit behind that barrier where I don't have to worry about price, and I can give an idealistic view of how a system should be put in and how to get the maximum energy efficiency from it. But there is, in the back of my mind, I'm always sort of thinking there is a cost bearing to this.
Yeah.
And obviously, the lower the flow temperature we go down to, the more it's going to increase the application costs.
Yeah, definitely. I've recently turned a bit the corner of Daikin because I always thought, they're fine. I didn't look into them far enough, actually, to be honest. And then recently, I don't know if you know a guy called Sam McGowan, Adaptive Energy used to run. I think he
rings a bell. I don't know.
He pointed me out the Madoka controller.
Yeah.
which enables all the stuff that I think is absolutely essential for a really good heat pump, i.e. room influence control and intelligent weather compensation control. So now all of a sudden Daikin for me, it's just bumped up to one of the big hitters. I mean, I'm not a heat pump expert at all. I'm nowhere near a heat pump expert. What I am an expert at is hydronics, and it just so happens for an air to water heat pump, hydronics is the most important thing to need to know to make your heat pump expert. So I am in that respect, but not individually as brands. So I'm actually booked to go to, as I think I told you, Daikin on late November, early December sometime. Because I think we're going to start trying them out and seeing what we can squeeze out of them. I know they've got an R32. Is there an R290 yet on the products list? Is there?
No, not yet. As you can imagine, there is a lot of caution behind going to some of these refrigerants. So one of the big things, especially of R290, is I can only imagine that they'll possibly only ever do it as a monoblock unit. And the thing is, you've got to think of the Daikin range, and for the UK, the monoblock is winning. But in France, the splits win by a long shot, and they sell a lot more heat pumps than we do.
Right.
So the market is obviously driven by how many units we are going to sell, and that's what will keep being the driver. So I know we sort of briefly mentioned about R290 actually on the YouTube chat, because a lot of the refrigerants, there's not a huge difference between them.
R32 is very, 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 very similar to R290, except for it hasn't got all the explosive clearances.
But the big thing actually is the global warming potential.
Yeah.
So if, and this has always been my big bugbear, if the refrigerant is lost, that's when that comes into account. Yeah. Now, for a lot of reasons, and I've asked the question to the industry many times, supermarkets love to use CO2, which is obviously a global warming impact of 1, which is probably the lowest we're going to get to. The problem being is the efficiency on it is absolutely appalling.
I've heard
now this. The question I actually put forward to the industry is, because of the extra energy, and no matter how you're getting that energy, whether it's electric or anything else, probably electric obviously, you're still going to be producing CO2. So how much CO2 would you have to produce before actually you negate the fact of having a low CO2 refrigerant? I never got the answer to it. It could be a stupid question.
Even if all of it was lost, it's a tiny amount. Like it's just, and it's unlikely to be lost. So, and you'd have to try and lose all of it to get. It doesn't really make much sense at all.
It's another one of my big bugbears, I'm afraid, is it's the car industry. It's actually caused a lot of problems, because if this whole take your car into the garage, get your refrigerant recharged in your car, I mean, it's a big no-no. Knowingly releasing refrigerant into the atmosphere is a heavy fine. I don't say it now. I think it's something like 10. It used to be. I could be wrong now. It used to be £10,000 and up to 7 years imprisonment.
Is that what they do for cars? They just let the excess off into the atmosphere?
Well, no. So if you've lost your refrigerant, most of them will just obviously vac it down and charge it back up.
Right, I guess it was saying,
and effectively, they haven't properly pressure tested it, and they're knowingly allowing refrigerant to be released into the atmosphere.
Yeah. They're not bothered with the car, and they assume there's less refrigerant, I suppose. But
yes. So what they should be doing is pressure testing, finding if there's any leaks. I mean, that pressure test will be a low-grade pressure test, so the car should then be in the garage for 24 hours, and then checking the pressure the following day to make sure it hasn't lost any pressure. And then at which point, if it has, they need to find the leak. And that should happen on a refrigeration system. I mean, we should never, ever lose the refrigeration in the system. So I'll tell you what, something I wanted to say to you.
Yeah.
Just purely because I didn't want it to confuse anybody more than anything else. And I'm just going to bring my own notes up. I did just draw a couple down. I've got to try and find which screen is on. That one there. So somebody said something to me recently, and I sort of thought, I'm going to nick that. Instead of sort of thinking, because we talk about refrigerant and straight away you think about refrigeration. I mean, to be honest with you, you just sort of want to think about it as a highly efficient heat transfer fluid. Effectively, that's what it is. It's not anything special. It's just called refrigerant because effectively that's what it actually is. But all we're actually doing is just transferring heat with it.
Yeah. Okay, so actually we should call it heat transfer fluid. I mean, anything can be pressurized into liquid and vice versa, or it's any substance, even rock in theory. You know, obviously the pressures and temperatures are slightly different.
Yeah, but I mean, yeah, anything, gases and all everything can transfer heat, and obviously the biggest one is the temperature and pressure is related. So with the refrigeration cycle we've got going on, all we're doing is messing about with the pressures to be able to boil that liquid off, change it into a gas. The compressor compresses it, increases the temperature, increases the pressure, and then you've got a nice
I do agree with you. When we made the heat pump how it works video a couple of weeks back, it saying refrigerant almost complicates it for the homeowner. You could say oxygen or anything, it all works the same way. It's just stuff. Increase the pressure of anything and it increases in temperature, etc., etc.
Well, you know that perfectly well with water. I mean, that's what you've been dealing with for all these years, and it's the same thing with a hot water tank. Yeah,
exactly. Absolutely. I definitely, so condensing and evaporation temperatures, you sent me a message the other day about like 37 degrees, how that's relevant and how we can move that around.
Right. So
that all sounded really interesting.
So as a very, very rough rule of thumb, with an air conditioning system, I mean, especially Daikin air conditioning systems, we tend to target roughly 37 degrees. And I'm taking it out of a pinch of salt because we can change this, a little bit. And then we tend to want to target an evaporating temperature of +5 degrees. Unfortunately, the evaporated temperature is always just going to end up eventually following a way where it's just going to go lower and lower and lower. There's nothing we can do about it. It's going to get so low to the point where the outdoor heat exchanger then freezes, and at that point, that's when we need to defrost.
Right.
But with any machine, we want to keep that heat exchanger as above zero, so we don't have to go into that defrost process. So the machine's always trying to do that, but eventually it just happens.
Right.
The nice thing about remembering the condensing temperatures of 37 degrees C with an air conditioner, and like I say, it can go up a little bit and it can go down a little bit. Especially so a lot of the newer systems tend to do this a lot more, because obviously I'll try and explain this carefully. If we keep the condensing temperature as low as possible and the evaporating temperature as high as possible, that's maximum efficiency. Yeah, the closer we can bring these two together, that's how we measure efficiency. That's how you increase efficiency.
Right.
So if we have an air-to-air system flowing at of a coil temperature of 37 degrees C.
Yeah.
I want to bring this back to an air-to-water system, because that would actually be a water flow temperature of 37 degrees C.
Right.
And you know as well as me, the lower we get that water flow temperature, the more energy efficient the whole system becomes.
Yes.
Yeah, and it's actually all about just bringing this condensing and evaporating temperature as close as possible.
Yeah, right. Okay, got you.
It purely is. Yeah, it's nothing really complicated
right,
about it.
Right. And then if we bring the condensing temperature up, can we get it to the point where it sits healthily enough above zero that we would never, theoretically speaking, that we wouldn't need to do defrost cycles, or will it always spiral down into that kind of area? Is that just a thing that
it will always spiral down? All it's going to happen is effectively as you start bringing the condensing temperature up, eventually that no matter what, the evaporating temperature is always going to eventually come down.
But if we bring down our flow temperature, does that, so if we bring down our flow temperature, we put in bigger radiators, bigger or tons of underfloor heating, we bring it down to like, I don't know, 21 degrees flow temperature needed for the house, just say again for theory. Does that automatically and conversely raise the condensing temperature? So hold on, let me think about this. The evaporating temperature is the temperature outside, isn't it? Is the unit outside. So I'm getting mixed up here.
So you're evaporating the liquid off. So the condenser is basically rejecting the heat into the air or the water. It's a medium at the end of the day. It doesn't matter what it is. You're still rejecting that heat into that medium.
The condensing temperature is the higher of the two temperatures, and that's the one we want to bring down, i.e. by putting in larger radiators, for example, if we're talking about air-to-water system. Does bringing that down automatically bring up the evaporation temperature, or is that just completely separate depending on...
It's completely separate. So you've got a device called the expansion valve inside any air conditioning refrigeration. No matter what, you've got an expansion device.
Yes.
All that expansion device effectively is doing, it's a bit like a tap, really. It's just closing the flow of refrigerant, allowing us to actually expand the refrigerant. But I won't go into too much detail. The simpler way of explaining it is lowering its pressure. So we're now on the suction side of the system. We're on a much lower pressure. And I used to say this many times in training courses many years ago. If you boil a kettle in atmospheric pressure, it boils at 100 degrees C roughly, should we say?
Yeah.
Atmospheric
Yeah, I
pressure
know this
being
one.
1 bar. And
Yeah.
if you take it up a mountain and that atmospheric pressure is maybe, oh, I'm trying to remember this off the top of my head, 0.6 of a bar,
I
and
think,
it will boil at something like 64 degrees.
I think it's Everest is the 64 degrees one, and then the Dead Sea is like 106 degrees or something to boil or something
Yeah,
like
yeah,
that.
yeah. But
Uh,
that's the principle. We're decreasing that pressure, so allowing that highly efficient heat transfer fluid to effectively boil. Yeah, and
so
so the different types of this is where we talk about different types of refrigerants again. The different types of refrigerants will allow us to boil it at certain temperatures. So they're always trying to look for this wonderful refrigerant,
right.
efficient transfer fluid that can boil off at a very, very low ambient temperature,
Right.
and obviously still be able to get quite a high condensing temperature to be able to.
So then, because it can boil off at a lower temperature, we don't have to suck as much on the suction side and compress as much on the compression side. Basically, we don't need as much differential because it's about the phase change, right? More so almost than the picking up of the heat, or as much as.
As much as, I mean, your capacity is coming from picking up with the heat of the outdoor unit. It was a good explanation I seen. I think it was a fully charged show. Sorry if I mentioned this, but they basically sort of they basically said try to forget about the compressor, because the compressors, everybody wants to look at the device that's motoring and doing something, but actually no, it's just moving the heat transfer fluid around, if you like, and the heat is being obtained by the outdoor unit, and that's happening because we can lower the pressure to a very low pressure,
get
it to boil off. If we get it to boil off, it absorbs a lot of heat,
Yes.
then got that gas again to go back into the compressor to increase the temperature, increase the pressure.
I think the phase change thing is important for people to understand, though, because when you evaporate any liquid or any gas or whatever, it has to obviously be a liquid. I say gas when I talk about oxygen, obviously, but when you evaporate a chemical or substance, you absorb thermal energy without increasing the temperature. So it takes in energy, even if it didn't change in it, it might only go up 0.5 degrees. When you condense that back down inside, it releases that as thermal energy on the other side of the heat exchanger. So you could, in theory, have almost no temperature change either side, but still transfer more energy. And that's just a thing that people need to conceptualize. I think it's exactly the same as condensing boilers. It's
It's that magical effect, isn't it? Superheating, subcooling.
Yeah, that's it. Yeah. Phase.
Yeah. I try and stay away from it as much as possible, because it just makes my life a lot easier to explain things.
Yeah.
And I don't have to go into too much detail about it.
Yeah. What's the relevance of 37 degrees then specifically? Like, where does that come? Is that
just the thing is, I've worked for Daikin all my life. I've not done anything different, so that's the sort of target temperature we target. To be honest with you, what you'll quite often find is a lot of the other manufacturers will just sort of tend to follow suit. The interesting thing about Daikin, I think, is that Daikin have invented a lot of the refrigerants. So, like the likes of R32 and 407C were both Daikin inventions. They learned by a mistake is it 407? I've got to try and get this right. Please, I might have to fact check this myself. I think it was 407C. You had to buy rights to use it. Was it 410A?
Right. Okay.
I can't remember which one. It's 407C. I think it might have been 410A. You had to buy rights to use it, which is why a lot of manufacturers, used 407C and didn't go to 410A.
Yeah.
Again, R32 is a Daikin refrigerant, but Daikin learnt by this, and it was the whole Betamax and VHS scenario again, and they released the patents on it, and they just sort of said, just use it. We need to get it into the industry. It's a better refrigerant.
Yeah.
So that's what happened with R32.
It is quite. When did R32 come out?
5 years ago, maybe. I'd have to double check. 6 years.
I mean, it's a bit of a leap, though, isn't it? Because that can achieve 70, 75 degree flow, 70 or 75 degree flow temperature, right? Can it?
70, yeah. We start getting into sort of very high pressure. There's a maximum point. You will hit a maximum point, and that refrigerant just can't go over it. There is a specific name for it. I can't remember it off the top of my head. I think I've seen something like 72, 73 off of R32 before. But the pressures you're getting at that point is just immense. Yeah, they're incredible. Well, it's the same with CO2. So Daikin actually made a CO2L thermal unit.
Oh, right. I didn't
Yeah.
know that.
No, we never brought it to market.
Right.
One simple reason we never brought it to market, we could never get the COP above 2.
Yeah, that's what I've heard. I've heard that they can do as high as you like temperature nearly, but not at any efficiency.
No, it was just, it was so bad. They just went, no, we just can't release this to market. But Daikin, I don't know if they still sell this unit. Yeah, again, I would have to fact check myself. But going back quite a few years, Daikin used to sell a CO2 unit. I think it was called the Sani Cube. It was only ever sold in Japan, and it was a CO2 domestic hot water unit.
Right.
But it was using very, very cheap electric at night to heat their domestic hot water up.
Right. Yeah.
But it never sort of ventured out of Japan effectively.
Doesn't it? If you run, say, like an R32 unit, and let's just say, for example, you wanted to run 65-degree radiators, which obviously we know is not great. Isn't there the argument as well that because the compressor is compressing all the time, that it would just die early as well, or is that not a thing?
It's not something I've ever particularly looked into. I say I don't know if you actually are aware of what my job is.
No,
it's an unusual one, isn't it? I purely just actually work for product quality within the UK. At the moment for all the products, but I do specialize in the heating products. Compressor reliability is incredible, actually, in all fairness. I mean, you sort of think how hard these things operate, and for how long. The factory give us sort of guidelines, and if anybody ever sort of pushes us on a question, we're always reluctant to give it, but if anybody ever pushes on a question about, look, what's the sort of life expectancy? I mean, it will vary on how hard you run it and for how long you run it, but normal expectancy is sort of between 15 and 20 years, really.
Yeah, great.
Yeah.
So, but if you've got like a cycling crappy system, obviously.
Yeah, well, it's stop and starting as well. That's the one thing we want to avoid, like the plague, really.
I mean, but that fits in with SCOPs and stuff and everything else anyway. Like, it's where everything's going. And things, have you seen things like improving recently, like with people talking about lower temperatures and, longer run times? Weren't really conversations we were having in the industry before, not on a wide scale anyway.
Do you know what? I had a lovely little debate on Facebook recently. That was a good one, actually, honestly.
And debates on Facebook.
Yeah. But this person was basically sort of saying about, I want to be able to use 5 degrees delta T on the radios.
Yeah.
Now, something on our new system, so the new monoblock, the new high temperature system, those units, if you set it to radius, just puts a default factor in of 10 degrees delta T. You can't change it. So the conversation went, well, I'd like it to on 5 degrees. And I was like, well, it's no problem. I mean, you just have to tell our unit it's running on fan cores. The difference between telling our unit running as whether it's running on fan cores or radiators is virtually nothing. It just sets the delta T in. The big difference is if you set it to underfloor heating, it actually changes the reaction time of the system.
Right.
When it knows there's a larger water volume in there. Yes. I mean, effectively, if you actually had a big buffer, if you were going to go for a big buffer, you'd actually tell it was underfloor heating. You could actually tell our unit it's going to work on slow reaction times. Sorry, I digressed a little bit there. What was we saying?
I don't remember. I want to go into that conversation now about reaction times. So reaction times.
The flow temperature you were talking about, weren't you? The 10 degree delta T. Sorry, 10 degree.
Oh, yeah, that's right. Yeah.
So I had to ask the factory. So this is one of my jobs. I'm the sort of link between Daikin UK and DNV, the factory that we deal with. DNV will then potentially have the chance to escalate to Japan if they need to. It's the path we have to take. Anyway, so went back to DNV, who then just spoke to the design guys to try and actually find out why or what was the decision behind the 10 degrees. And as far as I can tell, with no amount of accuracy here, it was purely down to noise.
Right. Okay.
So
noise in the building.
The hydraulic system. Yeah. So obviously just try and help prevent noise going through radiators and everything else like that. And I sort of said, well, could we not still change it? The problem being is, I think, is they were looking at the HHT unit at the time, and the only way you can actually get the 70 degree flow temperature out of it is to have the 10 degree delta T.
Wide delta.
Yeah. I mean, but as you said, this is my message. I want to make it really clear. What you want to achieve is the lowest possible flow temperature for the most reasonable cost, obviously.
Yeah, exactly. With noise, you can just swap radiator valves or whatever. There's other things.
Well,
It's going to be
to be
whistling.
honest, with you, this is something I can quiz you on because this is something I've struggled with in the past. So I
Yeah.
know I think you actually did a tutorial on it, didn't you, with different radiator valves
Yes.
allowing different flow
Exactly.
rates through.
The velocity you're going to hear for a delta T10 through a radiator, like a delta T5 for a radiator, you're not going to hear it through the radiator. It's not going to be the radiator's not going to be that noise. 15 mil pipe isn't going to really make any noise. The only noise is going to be generated at the two valves. So you just need higher flow valves. I wouldn't suggest, which is the fashion at the moment, pressure independent flow limiting valves, because they always have tiny little orifices that can easily block and restrict massively and put more pressure in the pump, which also lowers your scop. We want almost no restriction there, or if you have restriction only on one side, and then you just lower that. But I think, like, for me, the aim of design is to get the heat from that box out of the radiator with as little interruption, as little mixing, and as little resistance as possible. The easier we let go of the heat, the easier it will let go of the heat and the higher scop. Like, that's the sort of conceptual way I look at it.
Do you know what? I don't know why, but I've always been reluctant to actually give my opinion on this, and it took me a while to really sort of get behind this opinion.
Yeah.
And no radiator valves, no TRVs, literally a complete open system. Thermostat control might become a little bit more of a problem. I understand that, but if you actually live in an open house, which a lot of modern houses tend to be this way now,
yeah,
and then just run the system on weather compensation,
and
as long as the radiators are balanced and sized correctly.
Exactly. If you've got a warm room, don't even balance for the delta T of the rad. If you've got a warm room, balance down the radiator. Balance each radiator for the room temperature. Forget about the flow and return. That all equals out by the time it gets to the unit anyway. And then taking that further, if we can get enough insulation, enough pipe in the floor, radiator on the wall, you can lower the flow temperature so much where it self-balances anyway. So if you imagine you've got underfloor heating with a 22-degree flow temperature, if it gets too hot in that area, it's just going to stop giving up heat anyway. It self-balances, like, it just is more comfortable.
Yeah, it just reaches the maximum absorption, doesn't it?
Yeah, like that's kind of always been there in the background, isn't it? It's like almost like a theory that the idyllic kind of way to do it, but it is just proving to be the best way to do it. So the unit we've got now, we've got a Valent running our office at the moment, which is only up the road. We have no cavity wall insulation. We've got five blown double glazed windows, and we've got 100 mil of loft insulation, and then not the smallest rads, just normal size rads everywhere. I think we're on track for a scop of basically probably 5. We're getting a scop of 5 on that horrible old 60s building, but that's because we're pure weather compensation with the valves all fully open.
I'm running it all the time.
Yeah, we run it all the time, but with a nighttime offset. So
okay,
the flow temperature at 7 o'clock or whatever goes from 37 degrees down to 33 or something like that to target its 18-degree nighttime temperature setback. So it just goes lower temperature, higher temperature throughout the day. And then, yeah, you know what, it turns down at 6 or 7 at night. So it's not a perfect replication of a home. However, we're there all day, every day, and it's heated all day when you would normally go out to work. So we're kind of thinking that kind of balances out. But yeah, that's proving that all of our installs that go in are also done like that. So they should come back soon, and we should find out how well they're doing.
Yeah, that do you know what, that's something that really interests me, and that's something I'd really want to get some factual information on, because it's a debate that keeps coming up. I mean, if anybody ever sort of talks to me, because a lot of people in the industry would just sort of say, run the system 24/7. That's how you should run a heat pump. And I'm sort of saying, oh, no. I mean, if your boiler was 14 kilowatt and you put a 14 kilowatt heat pump in,
yeah,
you've got the same capacity. Why would you suddenly change the way you operate it? But I've always said, look, it does depend on occupancy pattern. And exactly. As you've just said, if you're in an office all day long, you're in the office all day long, you're going to want it on all day long. Whereas myself, normally I'm not at home, and I wouldn't normally heat the home during the day. Why waste putting energy in? I know that I reduce my COP figures when I look at my COP figures.
That's it.
But it saved me money.
That's exactly it. I think when people say run all heat pumps all day, that could mean a plethora of things. Like, I think a consumer would think, oh right, so have the thermostat sent to 21 all day round. No, when we say run the heat pump, we mean have it on, but the flow temperature can vary and your indoor temperature can vary. But if you're only in for 2 hours of the day in the morning, and when you get back, you go straight to bed, for example, high flyer, jet setter, I would only have it on for those 2 hours. Like, I literally switch it off. I'd prefer a cop of 2 for 2 hours than a cop of 5 for 24.
But you've hit the nail on the head. We'll come back to this whole air-to-air thing again. It depends on how you use your home.
Yeah.
So if you are a jet setter and you are going to be heating your house for 2 hours of the day, I mean, air-to-air is just perfect. Yeah. I mean, that's it. You've got the ideal heating system.
Yep, totally agree.
But if you're actually going to be home the majority of the time, well, actually, probably underfloor heating with a heat pump where you can get that 30-degree condensing temperature going for that underfloor heating.
This goes against the conventional way of designing a heating system for a heating engineer, though, because you always design for the home, not for the person. So that's the only other sort of other side to it. So
you've got to design for the home for the future, regardless of the person at the time.
Exactly. So it's kind of like a balance. What do you do? But I suppose that's down to individuals to find out. When you what is air conditioning we're talking about now. What is the definition of air conditioning? Do we control CO2? Do we not? Like, this is like everyone's arguing about it.
Do you know what? I love Richard's response, and I mean, he's not necessarily wrong, because the thing is, when anybody was to say to me air conditioning, that's it, I would just be thinking my air conditioning unit is up on the wall, heats and cools the bedroom. It's not. I mean, if you actually go into the original way of thinking what air conditioning is, or what it should be, is actually about air purity and humidity. Sorry. Yeah. So it's air temperature, purity, and humidity.
Right.
You literally are conditioning the air to whatever means you want.
So a normal air-to-air will always have a filter. So would that be pure enough for air purity?
In a small way, in a
way, right?
Possibly simple way. Yeah, it's not the air purifiers. Do you know? In all fairness, I'll hold my hands up. I'm not great with air purifiers. I got some very gentle ideas of it. And I did flag up a couple of little things actually, just so I could. I had a horrible feeling you might have asked me about this as well. So I did just bring some things up. I don't know if this one's going to show it. So they have like catalyst filters in.
Right. Oh, this is a proper, as it were, filter, right?
Well, a lot of the units are sort of bringing in more and more different types of filter.
Right. So when you see this in marketing, because people point to the marketing and say they call it an air conditioner, actually the reason that might be doing that is because real aircon really does purify the air, and they want to borrow some of that sort of branding of being an air conditioner of full purification, but they're never going to do as much as a full series of filters.
I think it was all about it's an air conditioning company.
Yes.
Yeah. So us as being an air conditioning company, we sell all the products to be able to effectively sort of say we're an air conditioning company, because we do fresh air systems for commercial. We're just about to start selling Duco MVHR. The sort of missing piece of the puzzle, if you like, is humidification. There's very few units that we sell that do it. And in all fairness, when we first started talking, I mentioned to you the Aruru Sahara. It took me years to learn how to pronounce that, by the way. Yeah. But that unit in particular has a very high level of filtration.
Right.
And it can humidify and dehumidify.
Right.
I remember the original unit off the top of my head, because I was heavily involved with the original unit. The newer units, I can only assume possibly work roughly in the same way. I haven't looked into it, so do forgive me if it doesn't work exactly the way I'm about to describe to you. But what it used to be able to do for dehumidification, it would actually fill a portion of the coil, like the indoor coil, with liquid, and then it would actually switch the machine over to heating mode, and the other portion of the coil would heat, so that would dehumidify the air, without changing the room temperature.
Right. Yeah. Because they cancel each other out.
Yes. Yeah.
Right.
Obviously, if you're just in cooling, you could dehumidify the air. The humidification is a little bit more complicated, and there's a few different ways that it can be done. I must admit, Daikin did take a very unusual approach. They use what's called a heat wheel on the outdoor unit.
Right.
So it's an absorbent material that basically will absorb the moisture within the air, and it's then heated with airflow passing over it. blown into the indoor unit.
Right. Okay.
So it's bringing in fresh air. So you've got fresh air,
Yeah.
high levels of filtration, and the possibility to humidify the air. So
Would we need that in the UK? UK is not very dry, right?
Not when it rains so much, no. But that that actually leads to a different problem where we've potentially got too much humidity in the air.
Yeah.
So sometimes you want to take humidity out of the air. So actually to be able to dehumidify is actually quite a nice feature. But I mean, you could just buy these Argos cheap dehumidifiers anyway, if that's what you so wish. You just don't want to take it down too low. The thing is, as you start going lower, it enables the body to release heat easier. So, for argument's sake, you can basically a comfortable humidity level is roughly between 30 and 60, maybe.
Right.
I think they sort of advise 30 and 50% RH. Yeah.
Right.
If you go below 30, it's not a comfortable humidity level for humans. It's not somewhere we really want to go. But anyway, if you're at sort of 40% humidity level, say your body can absorb reject heat a lot easier, so you can actually feel cooler. Which basically means you might have to overheat the house.
Yes.
To bring the temperature up a little bit more.
Right.
This is something I've given this in training for many years as well. I've always sort of said in the next sort of 20 years, I think we'll start seeing this come into a lot more effect where we'll get to the peak of what we can do technology wise, and then we're just going to have to sort of go to the next step. What's the next step?
Yeah.
And humidity control is one of those steps.
Great.
You said about in the UK, when would you want to add humidity? Well, anything below 0 degree ambient. So as soon as you're going below 0 degree ambient, unless you've got snow, you're pretty much running with a very, very low humidity ambient temperature, ambient condition, which will obviously enter into the house. There's an easy way to overcome that though. Just hang your washing out indoors.
Yeah.
Just add a bit of humidity.
Well, I mean, even if it's below 0 outside, so what would the humidity drop to outside if it was, say, -1? What would be normal, like 20 or something, 20%?
I would have to Google it, to be honest. I know it's just very low.
Right, but indoors will be higher than that, obviously, because we're cooking, cleaning, showering, breathing, sweating. So there'll be some, but you can't have all of it, obviously. Like there's, I guess, it still could need introducing.
Yeah. But I mean, that was the beauty of that unit, the Aurora Sahara. It actually measures the humidity level. So the Aurora Sahara.
Oh yeah, okay, yeah. I've seen
that measure the humidity level, and then it can humidify or dehumidify as it requires. What's bringing fresh air?
Available in the UK?
Yeah, that one's available in the UK. It's not. I'm going to try and say this very politely. You would want to see the indoor unit before you chose to buy it.
Right. Okay. Yeah. Can we leave that in?
If you, well, no, rather you didn't. If you could word it slightly differently, would be better. It's a fairly big unit, so aesthetically, would it fit into someone's living room? Has always been my question. That'd be a better way of saying it.
We'll leave that in there.
Yeah. But there's also a limitation. So the outdoor unit has to be, or always used to be a limitation. I'm assuming it's still there. It had to be within 10 meters of the outdoor unit, because you had a hefty pipe going between the outdoor and the indoor, because that was bringing the fresh air and the humidity.
This one's not a multi-split, is it? Is that
no, it's just a direct split. That's all you can get.
The Daikin do a multi-split with domestic hot water function, so we can cool inside and put that heat into hot water.
Daikin do. Not in the UK at the moment.
Right.
I was very, very desperately trying to get the answer before I actually had this meeting with you to be able to, hopefully, I was hoping that it would be a firm, yes, it will be coming. Right. The unit is out there. You can quite easily go see the unit. If you just type in actually multi plus DHW, domestic hot water. Right. It'll appear. It'll take you to the Daikin Europe website, so you'll be able to see it on there. It is a product on there. For the UK, anything that's got domestic hot water on it, we have to specifically get it certified for UK use. So with water regs, unvented regs, and
well, that's good. I like at the moment, because the market, heat pump market's driven by enthusiasts and people that want to spend the extra money. That's kind of where they're all going. They love the idea that they can cool in the summer and then capture that heat. And although I see some engineers offering that sort of stuff, it really is driven by the early adopters, or what the guys that are driving at the moment. So to have that option is going to be super cool. Plus, it's a cool idea.
Yeah, hang on, be careful though. So that unit won't do that.
Right.
So to be able to capture heat and put it into domestic hot water, you would be talking a very expensive system. I can't see it going towards residential for a long time.
Right. Okay. So it's only commercial at the moment.
Yeah, well, to be specific, to be able to do this, when you sort of think about a heating system as two pipe, when you think about an air conditioning system, you probably think of two pipe. When you talk about heat recovery, it's three pipes.
Right. Yeah.
Yeah, so you're now having to run three pipes.
The other way. Yeah.
Yeah, and then what you've then got with those three pipes, they're going into something called a branch selector box. You can have multi-branch selector boxes. If the box is closer to the fan core, it just basically means two pipes going to the fan cores. Whereas if you have a header of them, you're going to have to run two pipes from each selector box to the indoors.
Yeah.
Yeah. Now it might be something that will eventually come to an outdoor unit where that could all happen. But what it's basically doing in that refrigeration cycle is that condensing is going through the domestic hot water to heat the hot water. Yeah. So that's then effectively converting it to a liquid.
Yeah.
It's then got to go for an expansion device, and it's then got to reroute that refrigerant as a liquid through the indoor fan coil to be able to cool the space, and then to bring that gas back to the outdoor compressor to be able to pump it and do the cycle again. So it's a lot of equipment in one unit, and
a house.
Yes, and the biggest drivers tend to be they want a small outdoor unit. They it's the impossible thing, isn't it? They don't want a big outdoor unit.
They don't want the negatives, they want the positives. Yeah,
yes,
everyone.
Yeah. It's I mean, that was the nice thing about ground source. And unfortunately, I think it's just the inherent cost again for drilling the boreholes.
I mean, I think it's basically dead ground source, isn't it? Essentially, there's not really.
I don't know.
Don't get me wrong, but nowhere near where it was.
No, I mean we've actually made a ground source heat pump for donkey's years. We never sold it in the UK. So the first unit was three phase. So we just decided it was no point even trying to sell it in the UK. The second phase now is single phase. They are on our books. We don't post them in a price list purely because we know the most important factor of a ground source heat pump is the geothermal work. And if you don't get those geothermal surveys and they're not done right, you're not actually working with a competent company that will actually understand and absorb wasted costs. I mean, I was chatting to one company, and I sort of said, how many boreholes are successful? And I think he said something like 7 in 10. So 3 out of 10, he said it would just be a waste of time, waste of money, just gone. That's it. He's just throwing it down the drain.
Yeah. Wow.
And I don't talk about slinkies.
No, I don't know how it went for so long without someone even questioning it. We're running out of time now.
So sorry.
Is there anything else you want to share with the viewers or whatever before we kind of wrap things up? Anything advancements in Daikin or about yourself or anything like
that? Nothing really about myself, to be honest with you. I just keep plodding on doing what I need to do.
You're staying in Daikin then?
I won't be moving for the foreseeable future now. Yeah, they employ me satisfactorily. One other thing I just wanted to mention, because you were just saying you were interested in Madoko.
Oh yeah.
I actually have one fitted. Do I need it fitted? No. There's nothing really clever about the Madoko controller. You can just fit an air sensor.
Okay.
So but you could just fit a KRCS01.
Enablement of a nighttime flow temperature setback.
It's all on the MMI on the controller.
But that's on there anyway.
It's
for some reason, I was told that was room influence as well. The room influence.
Yeah, well, if you've got the air sensor on there, that's it. You've got all those features.
That's already built in. Oh,
yeah, it's already built into the machine. It's just purely it needs to measure the air temperature.
Right. Well, in that case, there's a load of settings that I need to show our viewers that they should have on their Daikins that I think aren't on 99.99999% of Daikins.
Yeah. Well, this is the biggest problem I've got, and this has been a big problem for me for many years. I keep trying to say to the factory, look, you need to simplify some of these things. We were just talking about how the levels of the training course is going to be done, and I was just telling the training department yesterday that look, if we do a level 3 training, it should be advanced settings, and this is we're hitting the clients that want to understand these advanced settings.
Yeah,
Daikin, oh my god, they have got so many settings, it's unreal. It's it's a job in itself. Understanding
I love it. Yeah, I love extra settings.
if you understand them, there's absolutely some phenomenal features within the machine. What it can do.
I'd like to go and do an episode on that. So maybe I either do that at Daikin then, or where do you live?
Bristol, I live, but I got no problem going up there. I quite often have to go up to.
Either way around. Well, Bristol's nicer than Woking.
Well, the training centre is really nice, actually. The Woking Training Centre, it's something to see because you can see all our products there.
I'm actually hoping to get there to the Woking one to do some recording at the Woking one. So maybe I'll try and squeeze it in then. I don't really want to do a training course. I'm not fitting, so yeah.
No. Anyway, I think it'd be a waste of your time, to be honest with you, with what you know.
Yeah.
The only thing I suggest is
I want to see the controller and see the settings, and then show maybe some of the installers what they should be doing if they get to a Daikin and they're like, oh, the weather comp's not turned on or whatever. Or how can I refine this to squeeze the more efficiency? That's what I want to
do. I've specifically asked product management to actually start concentrating on videos for this. So it is something, it's in the pipeline. I don't know how long it'll take, but I wanted videos for end users to be able to actually set up weather comp, because most of it's on the end user interface side of things.
Right, okay.
Yeah, so you've got to think about this. I mean, these products are being sold in countries like Sweden, and if you don't give them access to weather compensation, they go mental.
Yeah, well, I mean, I agree personally with letting the weather comp, and same for Germany. They understand what weather compensation is. It's some of the installer base don't like the fact we're teaching the consumers that, because they perhaps feel like it's taken away from their offering of value. I mean, I think that's a bit short-sighted personally. I think that's where stuff's going. So you either get there early or on time, or you just get left behind. So
yeah, I think that's very short-sighted, because at the end of the day, you can do all the calculations in the world to be as accurate as possible. You're never going to be 100%.
Yeah.
I mean, I know you said about heat recovery and stuff like that.
Yeah.
But with my house, it wasn't intentional, but I intentionally bought a house perfectly south facing because I wanted PV panels, etc.
Yeah.
What I never realized was the heat gain in the winter on a sunny day is just immense.
Yeah.
I need no heating. The sun will just heat the whole house up.
Yeah.
But it is a well insulated house, so I got the advantage. But actually, once the house is at the temperature as well, it stays hot for a long time. I actually get the reverse, and that's the only reason I've actually got an air conditioning unit up here.
Right.
Is air conditioning unit, air to air. It's just purely because it gets too hot in here. Sorry,
I've got my next call's messaging me now saying
that's all right.
Well, thanks for coming on, chatting to me. Let's do another catch up, another one, a call like this, because it sounds like we could just keep going for hours, to be honest.
Yeah, well, I'll tell you what, a good thing is if we can try and tie this Woking thing in together, then I'll try my best to get up there as well. And that'll give us a bit more time to actually better go through the equipment.
For like this show, I feel like we could do a few of these, just because it sounds like there's a lot to drill down to and like record them and put them on the channel. So let's arrange another one. And yeah, I guess I'll see you. So we'll organise that and do that again, or I'll see you at the training.
Yeah, no worries.
Chat to you soon.
All right, cheers, Adam.
Rob, thanks, mate.
Bye.